Is it?
Yeah, let's not do that.
Hi, my name is Myra.
Hi, I'm Maggie.
Hi, I'm Kim.
Whoa, guys, whoa. Before we get on with the movie, here's a message brought to you by the chevrons. Okay, so before we get to the good stuff, we have to get the basics down first. Let's begin by discussing what a carboxylic acid is. They are weak acids that have a carboxyl group. Some of you may be asking, what in the world is a carboxyl group? All it is a C double bond O, known as a carbonyl group, attached to a hydroxyl group. Now, because their functional group has this carbonyl and hydroxyl group, this makes them very polar. It also affects their solubility. Those that have 1 through 5 carbons are considered to be soluble. 6 or more become less and less soluble.
Not only does this carboxyl functional group help with polarity, but it also plays a big role in its boiling point. The polar carboxyl groups will form hydrogen bonds with other carboxylic acids, increasing the overall mass and its boiling point. This process is known as a dimer.
Now we will give you an example on naming carboxylic acids. First, we want to find the longest carbon chain, which is 1, 2, 3, 4, 5, and 6. 6 carbons, which is hexane. And since we have a carboxylic group, we replace the E with oic acid. Wait, we're not done yet because we have a methyl group. Remember to always start counting at the carboxylic group. As you can see here, it's on the 1, 2, 3, on the third carbon. Okay, so remember, hexane comes from the longest carbon chain, which has 6 carbons. Oic acid comes from it having a carboxyl functional group. And last but not least, the 3-methyl comes from the methyl group branching off the third carbon. And altogether, the IUPAC name is 3-methyl-hexane-oic acid.
Some carboxylic acids also have common names. They are usually the ones that have 4 carbons or less. They are known as form, acete, propion, and butyr. Also included in the common name are the Greek letters alpha, beta, and gamma, which are assigned to the carbon adjacent to the carboxyl carbon. Let's remember carboxylic acids with 1 to 5 carbons are soluble in water because the carboxyl group forms hydrogen bonds with several water molecules. When a carboxylic acid dissociates in water, H positive is transferred to a water molecule to form a negatively charged carboxylate ion and a positively charged hydronium ion. Since carboxylic acids are weak acids, when they are mixed with a strong base, like sodium hydroxide, they are completely neutralized and form carboxylic salts and water. When naming these salts, we replace the ic acid ending with ate. For example, acetic acid turns into sodium acetate. Sodium propionate and sodium benzonate are used as preservatives in food. Monosodium glutamate is used as a flavor enhancer to many foods.
Alrighty, now that we're done with the boring stuff, let's get back to the movie.
Carboxylic acids, esters, and lipids are found everywhere.
You come in contact with carboxylic acids on a daily basis, from the lactic acid your body produces while working out to the formic acid found in some bug bites.
A red ant sting contains formic acid that irritates the skin.
So how you been?
Pretty good. Just busy with school, same old, same old. How about you?
I've been working a lot. I've been intoxicated with formic acid.
Really, Kim? From a spider bite. All other bugs produce formic acid except spiders. Trust me, I wouldn't.
Carboxylic acids are even found in beauty products.
Okay. Somebody's in a good mood. Welcome, ladies, to the Chevron Spa House.
I was thinking about getting Botox because I've been noticing a lot of fine lines and wrinkles, and I just want to feel young again.
You don't need that. Our skincare products are high in AHA, which helps reduce the appearance of fine lines, wrinkles, and those pesky age spots. Plus, they're great exfoliators and increase blood flow to the skin. Trust me, by the time you're done with me, you'll look as good as Beyonce. Well, almost as good as Beyonce. Alright, ma'am. We'll be with you in just a second. And how about you? What did you come in for today?
I can't move my hair that much, but recently I went on vacation with my husband. I got sunburned. Now my skin is really patchy. What can you do to help me?
Aw, that's nice. I hope you and your husband had a great time on vacation. For you, I have this great exfoliating mask that is high in AHA, which will soothe your irritated and patchy skin. Try to stay indoors as much as you can, but if you must go outside, try to always wear sunscreen, because products high in AHA increase sensitivity to the skin. Alright ladies, how about you take a seat in our waiting room while we get your stuff ready? Can I offer you a glass of wine?
Yes!
The preparation of a carboxylic acid.
So, how's school going?
It's going good so far, except one class.
When primary alcohols are exposed to oxygen, a carboxylic acid can be formed. For example, when primary alcohol such as ethanol, ethyl alcohol, undergoes the process of oxidation, it will then convert into acetaldehyde, and lastly into acetic acid, which is the carboxylic acid found in vinegar.
How about some fresh fruit to snack on while you wait for your face mask to be prepared? Alright, here you go ladies. Here's some nice fruit.
Thank you.
Can I offer you ladies some more wine?
Okay, thank you.
Yes, please. I'm so stressed out on my chem class. I need it.
I'm sorry to hear that.
No, more, please.
Oh, okay.
More.
Oh,
That's fine. Thank you.
okay. I'll be back.
Don't worry, you'll be okay, my mom.
I'm just so stressed out. I don't know what I'm gonna do. Are you wearing perfume?
No.
What's that smell then? It has a strong smell.
Maybe it's the fruit.
Is it?
Another thing you come in contact with almost every single day are esters. They are what give things their special scent and sometimes flavor. For example, the sweet smell and taste of strawberries? Yup, that's caused by an ester. An ester and water are formed from the reaction of a carboxylic acid and alcohol. When it comes to esters, the H found in a carboxylic acid is replaced with an alkyl group. An ester's boiling point sort of falls in the middle. They have higher boiling points than alkanes, who can't form any type of hydrogen bonds, but have lower boiling points than alcohols and carboxylic acids, who have hydroxyl groups and can form hydrogen bonds. Although esters do not have hydroxyl groups that can form hydrogen bonds, they can participate in hydrogen bonding with water. The oxygen in the carbonyl group is partially negative and can form a hydrogen bond with the hydrogen atoms of water molecules, which are partially positive. Esters with 2 to 5 carbon atoms are considered soluble in water, but as the number of these carbon atoms increases, their solubility decreases. During the process of acid hydrolysis of esters along with water are heated in the presence of a strong acid, such as sulfuric acid or hydrochloric acid. During this process, a water molecule will provide the OH group that will turn the carbonyl group into a carboxyl group. Then a very large amount of water will shift the carboxylic acid and alcohol products into equilibrium.
Saponification. When an ester undergoes hydrolysis with a strong base, a carboxylic salt and alcohol are produced. Saponification is the reaction used to make soap. Remember acid hydrolysis from a minute ago? Well, we take the carboxylic acid produced from acid hydrolysis and convert it into a carboxylate salt, and then we neutralize it with a strong base, such as sodium hydroxide. Then we have soap.
Okay, now we will explain how to name esters. An ester consists of a double bond O connected to a carbon and a single bond O. First, we start by separating the two chains where the single bond is located at. On the right, we see that after the single bond O, there's 2 carbons, which makes it a neto. And on the left, we can see that there's 4 carbons, which makes it a butanoate. The O8 represents the double bond oxygen and the single bond oxygen. The alkyl group is a prefix, which makes it go first, and the O8 is the suffix, which will go last in the name. Together, the IUPAC name is ethyl butanoate. What are lipids? They're one of the 4 major groups of organic molecules. They contain hydrocarbons and make up the building blocks of the structure and functions of living cells. They're not soluble in water and they're nonpolar, and they come from plants and animals.
Physical properties of fatty acids. Since saturated fats are single bonded, they can fit closely together, which results in the need for higher amounts of energy and temperature for any melting to occur. Unsaturated fats contain cis double bonds, which make them irregular shaped. Therefore, they cannot stack closely together, creating the opposite effect from the saturated fats. Unsaturated fats are usually liquid at room temperature. A good way to remember the physical properties of fatty acids is to imagine saturated fats as Pringles. They stack one on top of the other. As for unsaturated fats, they are like a bag of Lay's. All of them are scattered around. As you can see here on the left, we have unsaturated fats, which have less of an effect on elevating blood cholesterol levels. They are found in plant-based foods and fish. Some types of unsaturated fats are monounsaturated fats, polyunsaturated fat, and omega-3 fatty acids.
And on the right, we have the saturated fats, which contributes the most to elevating blood cholesterol, especially low-density lipoproteins. They tend to be more solid at room temperature and are found in animal products. Just like saturated fats, trans fats can raise cholesterol.
And now here are some examples of unsaturated and saturated fats on Cooking with Kim
And Myra.
Okay, now today we're gonna cook. Let's start off with preheating the pan. Olive oil. Let's start off with some olive oil today, which is pretty healthy. Just add a little bit. Did you know olive oil is 100% unsaturated fat and contains no trans fats, which makes it healthier than other cooking oils? Okay, now that the olive oil is heated, we can make some scrambled eggs. Make sure they're small or regular. Just two. Did you know a large egg has 200 milligrams of cholesterol, which is why it's better to eat smaller ones since it is recommended that the average American consumes no more than 300 milligrams a day. Okay, now that the scrambled eggs are ready, just do one more flip. Okay, now that they're ready, we can add it to a plate now. Just so it could taste better, we can add, let's see. Oh yeah, an avocado, just a little slice. Did you know adding a slice of avocado will let the monounsaturated fat actually increase the HDL cholesterol, also known as the good cholesterol?
Okay, now let's see what I'm going to be making for breakfast today. First off, let me turn on my stove. I'm really hungry this morning. I think I'm going to make me some scrambled eggs. First, I'm going to need some butter. And I'm just going to add 1 scoop. Well, let's make it 2. Delicious. Butter goes good with anything. Did you know by controlling the amount of hydrogen, manufacturers can produce various types of products, such as soft margarine, solid stick margarine, and solid shortening? Now, to make my eggs a little bit extra greasier, I'm going to be adding some corn oil. Let's just add a little bit. Okay, now let me go get my eggs. I'm going to be using extra large eggs today. And I'll be eating 4 of them. Okay, let's open up the box and put in some eggs. It's 1, 2, 3, and 4. Alrighty, now that my eggs are all ready, I'm gonna be needing a plate. Thank you. And I don't like my eggs just by themselves. I think we need to add a couple condiments. So let's see, let's add some mayonnaise. Just a little bit. Oh, keep going. Okay, now some ketchup. You gotta love that high fructose corn syrup. Who cares if it clogs your arteries?
Remember, the amount of fat we eat doesn't impact our weight or cholesterol nearly as much as what kind of fat we eat. Next, let's talk about waxes. They're part of the lipid family. They're esters with long-chain carboxylic acids and long alcohols. They are found in many plants and animals, typically used for protection.
Steroids are also part of the lipid family. They include cholesterol, chlorophyll, and hormones. They can be medically useful to help sick people, but sometimes can be abused in sports, which is bad because it can cause a lot of damage to your body. For example, it could cause strokes, liver damage, blood clots, and much more.
And here are some real-life examples of steroid use. Whoa, what happened to you?
What do you mean?
I just saw you a couple months ago and you weren't this big.
I've been this big. I've been working out a lot.
Oh my god, why do I wait until last minute to study for everything? so stressed out. I'm so stressed out.
Okay, now that we got done talking about the types of lipids, let's go on with the cell membrane.
The cell membrane consists of a phospholipid bilayer that has a hydrophilic, water-loving polar head and a hydrophobic, water-fearing nonpolar tail. The outside layer comes in contact with the fluids that are on the outside, while the layer on the inside comes in contact only with the things inside of the cell.
It is important to know that the bond in the phospholipids have kinks in them, known as cis double bonds, which does not allow them to fit close together, giving it a fluid or liquid-like structure known as the mosaic model. Proteins, carbohydrates, and cholesterol molecules can also be found in this liquid-like bilayer. In this fluid mosaic model, there are both peripheral and integral proteins. On one hand, peripheral proteins will appear on either the inner or outer surface of the cell membrane. The potential functions of these proteins are to sense and adjust to its surroundings.
On the other hand, we have integral proteins that can be seen on both surfaces of the cell membrane. Their job is to transport ions and molecules across the membrane. Lastly, we have carbohydrate side chains that branch out from the surface of the cell membrane. Their job is to recognize other cells and communicate with chemical messengers such as hormones and neurotransmitters.
Now that we have discussed the structure of the cell membrane, let's talk about the methods of transportation across the cell membrane. Passive transport is one of the ways that ions and molecules cross the cell membrane without the use of any energy. They diffuse from a higher concentration to a lower concentration. Two examples of the ions and molecules that undergo passive transport are water and oxygen.
Facilitated transport. Ions and molecules that use facilitated transport also do not use energy. In fact, these ions and molecules can diffuse more rapidly than passive transport.
Active transport. Most chemicals use this method of transportation. Since they go in the opposite direction of their concentration gradient, they require more energy, known as ATP.
The cell membrane is very selective of what it lets in. To help you better understand this concept, here's a short video clip.
Hi.
What's up? End of the line, please.
Really?
Yeah.
Oh, come on.
Look, we got capacity, okay? We'll let some people in when it clears out enough. You get right in. If you go back to end of the line.
We come here all the time. It's not a big deal. It doesn't really look that crowded in there.
Hey, look, I don't make the rules.
Please.
No. Hey, what's up, shorty? What's up, pretty girls? See y'all when y'all get out. What's up?
What was that?
Like, if you want to come in, you're going to have to go to the end of the line and wait like everybody else.
I'm not going to go to the end. You may have power now, but you're not God. You're a doorman, okay? You're a doorman. 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 Doorman! So...
Alright, hopefully you enjoyed the show. Thank you for watching, and we hope that you have a better understanding of carboxylic acids, esters, and lipids.